All right.
Hi everyone, and welcome to this latest MCNPro webinar series. I'm joined today by Beth Bulwark, who is the Senior Archaeological Analyst with the Archive of Comparative Slavery. Have I got that right, Beth?
Yes. Yeah.
And you're at Monticello, is that right?
Yep.
Fabulous. So today we're going to learn all about R, which is a programming language used in data science. And I'm really excited about this because R was invented in my hometown of Auckland, New Zealand. So
Yeah.
I've got my Kiwi pride going on. Beth, one of the curious things I think though is that your background is not as a programmer, right? So you've learned this as a new skill in the museum setting.
Yes. Yes. So the archive that I work for, the Digital Archaeological Archive of Comparative Slavery, or DAX is what we call it because it's kind of a mouthful, is a large database of archaeological information from over 80 sites that have been excavated that focus on enslaved communities. And our mission is to facilitate comparative research. So we hope to help researchers really focus on looking at broad-scale patterning of material culture over multiple sites. And one of the ways that we facilitate that is our program to do statistical analysis. So when I dissertation back in 2010, I was not a programmer. I had no experience programming, but I sat in on a class at my graduate institution, and then I took a number of online courses, and I'll talk about resources more kind of towards the end of the presentation. But one of the great things about R is that it's a really active user community, and people are really great at offering help and creating resources for beginners, advanced users. So it's definitely something you can learn on the job.
Fabulous. It's really great to hear because I know a lot of people who are involved in the news data community aren't from a tech background. And so having something that's really accessible to us all is fabulous. So Beth, I will hand over to you now for your presentation. For those on the line, we have a chat facility if you have any Q&A. Please otherwise do mute yourself just so we get a good audio quality. And we will be recording this session ready to publish online so that you can share it with your colleagues afterwards. So over to you, Beth.
Great. Thanks, Angie. Okay, welcome everyone. So just to before I get started with the presentation, just to give you a sense of what the scope I'm going to talk about today. So obviously in 30 minutes or so, I can't really do a deep dive into R programming. So what I'm hoping to do is give you all a very brief intro to what R is and why it's become such a popular language, and give you a few examples of how to work with R, our syntax, and a few packages, which are all terms I'll explain, and then provide some information about resources and the R community that you can follow up on after the presentation, with the hope that you will be diving into R. And certainly feel free to ask questions afterwards. So I'll go ahead and get started. So what is R? So R is kind of two things. It's a language, it's a programming language, but it's also an environment that is used for statistical analysis and data visualization and graphical representation. And part of the reason environment is part of the definition is because the people who created R want people to see it not only as a programming language, but also as a holistic environment for people to use that really provides multiple ways of working with data, not only to perform statistical analyses, but also to manage data, wrangle it, clean it, and visualize it, which are all really key aspects of data science and research. So it's both a language and an environment, which is kind of key to keep in mind. And just very brief R history, as Angie mentioned, it was created by Ross Ayaka and Robert Gentleman at the University of Auckland in New Zealand, and R is named after the two creators, so Ross and Robert. Their name begins with R, that's where R comes from. They conceived it in 1992, and it was released initially in 1995, and then a stable beta version was released in 2000. And fun fact, R's version names are kind of known for being a little bit quirky. They've gone through a couple different iterations. Currently, with the most recent set of versions, the 3.0s, are named after Peanuts references, which are kind of fun. So the most recent version is 3.5.0, which is named after one that talks about feather spray. So all of the versions have kind of a fun name to them. So another question that a lot of people ask is why learn R? You know, we all have a lot to do. We're very busy. So why take the time to learn a new language or a programming language at all? And really one of the most important benefits of being able to write R code is the fact that you create what I'll talk about in a little bit, what are called scripts that allow you to record all aspects of the way you're working with your data. So although you can work with data in Microsoft Excel, and that's a completely valid way of doing data analysis, one of the challenges of working with point and click systems like Excel is that you can't always record all of the steps that are in your data analysis. And sometimes, understandably, and this has happened in some really well-known research projects that have worked with Excel, you may make a mistake with your data analysis, but you may not realize it. And it's very hard for other people to look at it if you've done it in a point and click interface, because not every piece of it is actually recorded. So one of the benefits of learning a programming language like R and creating scripts that you can save and rerun is not only do you not have to invent the wheel every time for your analysis, but everything that you've done, all of your steps are recorded. Other people can review them and run them themselves and either help you catch errors, which inevitably often happen, or help you think about how you're doing your data analysis. So one of the main reasons I learned R for my dissertation research, and one of the reasons why we use it at DAX, the project that I work on, is because that way we can share our code with our collaborators so that they can see how we do our analysis, which we're big proponents of open data and open science. One of the main parts of our mission is that we make all of the data from these 80 archaeological collections available through our website, dax.org. So we not only make that data available, but we also make our analysis what we hope will be open and transparent by making the code that we use to do the analysis available. So that's one of the reasons why I'm a big proponent of using R, or Python is another option. But obviously today I'm going to focus on R because that's what I'm familiar with. Another reason to learn R is because it's available, it's an open source language, so it's a free download. There are other programming languages that you can use to do statistical analysis. SAS is another example, which still allows you to use many of the same type of methods, but can be very expensive. The licenses are rather expensive, and because it's proprietary software, the user community is not necessarily as widespread or as open in terms of providing questions or answers to questions about how to use SAS. Because R is open source and users are able to develop their own packages and maintain them, there's a real value for the community to be able to ask questions and answer them, and to help people learn how to use the package you've developed. And so having it be free and open source software not only keeps costs low for those who are interested in using it, but also creates a really vibrant and active user community because people are engaging in helping develop the language and want to help maintain it. Who's using R? A lot of big companies that you're very familiar with use R for their data analysis. Google, for example, has used R for their Google Flu Trends project. You may have heard of that, but tracking, using R to analyze people Googling different questions or terms about the flu to be able to understand how the virus is moving and where it's popping up geographically. Airbnb also uses R to try and predict trends in where people might be looking to rent housing. Twitter uses R to look at the locations of, certain kinds of users or certain patterns of information spreading or networks. So really, a lot of large companies that you're very familiar with use R for their data analytics. So it's a very popular language with a user community of over 2 million people, which is another good reason why you might want to get started with it. So just to give you a sense, over the next couple of minutes, I'm going to show you the IDE for R, or the Integrated Development Environment, which is called RStudio. So I'm going to switch to that now. And what you can see here, so when you download R, you can just download the base version, which gives you windows to work with. It will give you a window to write scripts in, and areas to look at, any graphical representations or plots you are creating. But the nice thing about RStudio is that it gives you an environment to work with R in that allows you to see your data structures, your plots, and these are all things I'll talk about very, very shortly. Your help functions to help you see what packages are loaded. So it just gives you a holistic area to work in, where everything you need is kind of in one spot. So to give you a sense of these kind of how it's divided up, there are these 4 areas. So 1, 2, 3, 4, and they are called, this is the editor. This area is called the environment. This area shows you plots. Hopefully you can see my mouse. If not, I'm kind of going clockwise here. So the upper left is the editor, upper right is the environment, lower right is the plots and packages and help area, and then lower left is the console. And the editor in the upper left is where you can write, so here you can write scripts or lines of code, and you can save them. So for instance, I've just written here, this is where you can write scripts. And you'll see now that this area has turned red, which shows me that now I have changes to my file that aren't saved. So that's just a nice example of the IDE, a built-in function of the IDE that shows you, that reminds you, oh, I need to save my script because I've made changes that aren't saved there. But this is where you can write multi-line pieces of code and then save them. So I'll hit the save icon here, and now you can see it's turned back to the black color. And this allows you to write scripts, save them, share them, open them, rerun them, which is really nice, especially if you're creating scripts for data analysis that you're going to be doing multiple times. You don't have to write the script over and over. You can just use one that you've created. The difference between the editor and the console, down here you can see I can also type information into the console. So just to give you an example, one really easy way to use R is as a glorified calculator. So you'll see here I've typed in 2 + 2. If I want to run that line, I can either hit the run button, or I can also hit the command return key or the control return key if I'm on Windows. And if you see here, it printed out 4 down in the console. So that's the sum of 2 and 2. But the difference, I can also do that down in the console. So I can hit 2 + 2 and run it, and it will give me 4. But the key difference here is that it won't, when I exit out of RStudio, what's in the console here is not automatically saved. So if I don't either save the workspace, which is an option, anything that I type down here will disappear. As opposed to up in the editor, I can save the file to open whenever I want to use it again in RStudio. So it's important to note that you can still write code, write expressions down in the console, but whatever you write is not going to be saved unless you save the workspace. So that's one major difference. So then, in addition to using R as a glorified calculator, really the power of R is that you can create objects that then you can manipulate and do analysis on. And in order to do that, you have to assign a value to an object, which is called an R expression, which is what line 7 does here. And I should also note, you can see in my code that I've written out some information in plain English, so I've commented my code, and R reads anything after the hashtag or £sign as a comment, so it will ignore it when it runs the script. So a really important part of writing data analysis scripts is that is to comment your code well, so that when you inevitably have to come back to it, a week, a month, a year from now, you will hopefully have enough information there that you can remember the steps. And you'd be surprised at how quickly you can forget it if you don't comment it well. So it really does benefit you to really carefully comment it and make sure it's well documented what your steps are for data analysis and visualization. But that's another nice part about writing scripts rather than using a point and click interface, which can be harder to remember all the steps you take unless you write them down separately. But here we have, so A is our object, and then we're assigning the sum of 2 and 2 to that object. And with R, the assignment operator is this less than sign and a dash, which looks like an arrow. That's a little bit different than a lot of other programming languages, which use an equal sign. There are parts of R syntax which are a little bit quirky. This is one of them, but it's fairly easy to remember that this is the assignment operator. So when I run this line, you can see that down in the console, it ran the line. It tells me that it ran it, but it doesn't necessarily print anything else out. But you can also see up here on the upper right-hand side in the environment that a new row has appeared, and it's a value that's A. So it's telling me now that I've created an object that has, that's called A, that has a value of 4. So now you can keep track of the different objects and things that you're doing in this window, which is really handy. The other nice thing about this is that this will show your history of all the commands you've written. So if for some reason, maybe you have done a number of calculations in the console, and it's not easy to copy and paste, you can create a history here that you can also save. Let's go back to the environment real quick. So I've created an object that's called A that has the value of 4, and this is called an object. It's also known as, you can have multiple data structures, excuse me, that, so objects can have multiple data structures. This happens to be a vector, which is basically a list of elements that are all the same class. So for example, you could have a list that's 4, 5, 6, and 7 that goes into A. The key thing about vectors is that all of the elements in that vector have to be of the same type. So if you try and put like a character variable like an A, B, or C, and then a number variable like a 2, 3, or 4, it will coerce those two into a character variable so that the vector has elements of all the same class. And vectors are the most basic data structures in R. You can also use matrices, data frames, which I'll talk about in a little bit. And that's one of the really valuable components of R, is that you can create these objects that then you can manipulate with different methods to do various analyses on. And R is really built well to work with, especially with matrix data structures, but also with data frames. And that, because it's geared towards statistical analysis, those are two of the structures that people will use a lot to do their research. And I'll give you an example of that shortly. But just to go back to the basic syntax, you can see we have, like I said, the A has been assigned the value of 4, but it doesn't necessarily print it out. You have to make it print it out by typing A again. The other thing to note is that R is case sensitive. So if I say A, uppercase A, it will give me an error. And this is another thing that the console will do for you. It will tell you, oh, you have an error in your code, and give you the error message that a lot of the time will give you some kind of useful debugging information. In this case, it's telling me object A isn't found because this is a lowercase a. So it doesn't have anything assigned to this, this letter because it's not an object that's been created. But if I run just the line with the lowercase a, it gives me a 4 because that's what I've assigned to that object. So you have to ask it to print it out in order to be able to see what's been assigned to it, or to check if you want to. Sometimes you can also have what's called an incomplete expression if you forget to assign something. So for instance, if I forgot to assign anything to B and I ran this line, it would tell me that we don't have any arguments, you need an input, or you need a value to assign to B. So it's an incomplete expression. So again, it's helpful, the console will try and give you helpful information if when it runs what you've created throws an error. So now I'll move on to another really valuable part of R, which is functions. So you can, in addition to creating objects, you can then use functions to do analysis on those objects. And one of the really great things about R is that it has a lot of functions that are part of the package or of the download that you get, but that people can add functions as part of packages. So there are lots and lots of functions out there to do various kinds of analyses. And chances are, if you've thought of something you want to analyze and a way to do it, people have created functions and packages that you can use. It's mostly a matter of finding them. So just to give a little bit of background for those who may not be familiar with functions, a function allows you to do something to an argument. So the syntax is the function name, or sorry, the function name, which in this case is help, because I'm going to ask it to help me understand a particular function. And then the argument is what you give it to act on. So in this case, I want to understand, if we look at line 21 here, what the structure of my object is. So you can see I have the A, which is the object, and then this function is called structure. And so if I run that, it tells me that this is a numeric vector and that the value is 4. And so the structure is the name of the function. The object, or the argument, is that object A, that's what we've called A. And so the function acts on A. And if I wanted to understand a little bit more about the structure function, I can run this command or this function, another function, which is called help. So I'll run that here. And what that does is, if I go over to this window, you can see that, oops, I'm trying to run it again. Let me try a different. Sorry, I'm moving my GoToMeeting screen here. So that didn't exactly do what I was hoping. Let me show another example. So if I go down here, this is another function that's called square root. So it's just going to take the square root of A. So we'll run that, and it'll give us 2 because that's the square root of 4. But then if I want to see more about that function, there we go. I can use a function called help and put square root, which is the name of the function, as the argument. And in the window in the lower right-hand side, you can see now that it gives me more information on that function, what the arguments are that I have to use to be able to use the function properly, and then just additional information on how that function was developed and examples of how to use it. And another syntax is to just use a question mark and the name of the function. So again, that gives you the same pieces of information. So that's hopefully a little bit of just an intro to some of the syntax of R. So just to review, we can assign variables or values to objects. There are a couple of different object types in R. And then we can use functions to act on those objects. So we can do analyses of them if we put the objects in as arguments. And then if we need help with some of the functions, you can use the help function or the question mark to learn more about them. So now I'm going to show another example that will provide a little bit more information on some of the additional functionality in R. And this is a script that I used for a project where we were looking at a website and doing a content inventory of all the pages on the site. And we wanted to understand, it hadn't been updated in a number of years. So we were assigning pages different categories based on whether we thought they were still relevant or not. And so to do that, I had basically an Excel sheet of data that I wanted to bring into R to do some analysis of how we categorize those various pages. So to break this down a little bit, you can see on my first line, I have just a very basic explanation of what the script is doing. And certainly I could probably make that more detailed, but that just gives you a basic explanation. The second line, I'm bringing in a package for data analysis, and packages are a way to expand R. So usually packages will have functions that are associated with particular methods that you might want to, data analysis methods that you might want to use. In this case, I'm using what's called the dplyr package that you can download and install in R. And that's used to do data manipulation and analysis. To be able to import it into my current session. So you have to make sure that it's read in every time so that all of the functions that you want are loaded. You use the function called library, and then you pass dplyr in as the argument. So once I do that, you can see down here that it's run that line. So now dplyr is active in my session. And I can use all of the functions associated with that package. And there are hundreds of packages that have been developed by the R user community. And so you can go to the website that's associated with R and look at them all. You can also look at see options for packages again in this lower corner right here. And you can see that there are a number that some of which I've downloaded, many of which I haven't. But you can kind of read through that list and it will give you a very basic explanation of what it is. And then if you want to learn more about it, you can click on the list and it will give you a little bit more of information. So that's another way to learn about all the various packages. That's nice with RStudio is that you can kind of peruse, but normally you are kind of looking for a particular package that does the methods you're looking for. And that's where the user community can be really helpful, because you can look at pages like Stack Overflow or really just Google, the method that you're looking to use and R package and see what comes up. Google is really useful for asking questions about R. So I have my package in, and now what I want to do is read in the data. So one thing we saw here was that I created an object by assigning it a value. I typed in 2 plus 2. But another way that you can create objects is to read in data that you already have. So in this case, I have a spreadsheet that I want to read in. So I can use the function called readDelim that will read in the data. And another nice thing about RStudio, you see now that there's this yellow box that's popped up. So that's telling you all of the arguments for that particular function that you need to have to help that function work correctly. So you can see you need the file name, which I have in parentheses or in quotes. You need to tell it how the data is separated. In this case, it's a comma separated value sheet. So it's being separated by commas. You need to tell it if it has a header or not. In this case, my data does have a header, so it's true. But that's a nice feature if for some reason you're running a function and it's giving you an error message. It's good to go check and see if you have the necessary arguments filled out, and that little box can help you just look at that really quickly without having to go down or use the help function to see what needs to be there. And all of that, this whole spreadsheet is going to get assigned to an object that I'm calling links, because it's information on links on the website. So I'll go ahead and run that, and you can see that this has showed up down in the console, which means it's been run. The other nice thing about this environment is now that you can see a new row has shown up here that's called links, and it shows you that, oh, there's a new object that is in this session that's called links, which is what I was hoping to do. And you can also click on that to be able to view what it looks like. So you can see here basically my spreadsheet that has the information on all the different web pages that are part of this website. And I have a number of columns and 272 rows of information. So that's a nice feature to just be able to see if it's brought in what you were hoping it has, and it's formatted it correctly. And then another way of looking at that object to make sure that it's done what you were hoping it would do is to use that structure function again. So this will tell you about the data structure of the object. And that information shows up down in the console here. Excuse me, and you can see that the structure is identified as a data frame, which is one of the most useful data structures in R. It allows you to bring in basically what is a spreadsheet of data. So when you're working with a data structure like a matrix, one of the limitations is that all of the variables need to be of the same type, so usually numeric. The nice thing about a data frame is that you can mix and match variable types. So for example, with my links, most of these in this instance are characters, so they're words. But let's say I had a piece of information that was numeric, like a count or a sum or an average. It would bring in that information as a column, and it wouldn't throw an error. So you can mix and match the types of variables that you want to work on and do analysis of them in a data frame structure, which is really valuable for being able to do data analysis. You can also see here that it's telling you it's 272 observations of 8 variables. So the observations are basically the rows. We have 272 rows, and the 8 variables are the columns. And then here it gives you a breakdown of those columns, and it tells you what kind of variable is in that column. So for instance, for the tab variable is a factor, which basically means it's a character variable, but it's a categorical variable. So all of these, there are sets of characters so like the word home, that are repeated over and over. So you can see I have home, resources, archaeology for educators, and R has seen that there's repetition in this column and automatically assumed that that means that those can be grouped into categories, which are called factors. So in this case, it's imported it as factors, which can be really, and that's the default, which can be useful. Sometimes it's not, because you don't necessarily want those R to read them as categories, but you can change that into just character variables if you need to. But you can see here pretty much all of the columns I have are different kinds of factor variables, which is what I wanted, because I wanted this basically as a spreadsheet of categorical information. So we have the data object that's been imported correctly. It looks like what I was hoping it would. So now one of the things that I wanted to figure out is how we categorized many of the pages on the website using 3 categories, which were either keep, discard, or update. And so I want to first just get a rough count of how we categorized all of those links, but I want to focus on links that are internal to the website. So we had both internal pages and external pages. So you had links to pages that were outside of the website, but we also had a bunch of pages that were, on our domain. And I'm just curious what the count of the categories for that internal domain is. So one of the ways that I can do that is by using the count function, but I need to first filter, because if you take a look at this data frame, you can see I have a couple of different categories in here. Most of them are internal, but there are some that are links to external pages. So what I want to do is filter this, this data to just look at internal links. And so I use the filter function, and I have to give it the object that I want to perform the function on is the first argument. And then I'm asking it, do that filtering if this column, which is internal external link, if the information in that column, the words in that column are internal link, or if the word is internal, those 2 categories. And then I'm telling it, okay, once you've done that filtering, count the information that's in there by the action column, categorize it by the action column. So here you can see we've done, as I mentioned, the different categories. So either discard, keep, or update. So tell me how many links fall within each of these categories. Count that up for me. And I want all of this information, I'm assigning that to this object that I'm calling action count. So I'll go ahead and run that. And you can see here that it's come up in the console and there are no error messages, and that it's also shown up in the environment as a new object. And here we have a new object that's called action_count with 2 columns. One's called the action, which is discard, keep, or update, and then another column N, which is the count of the number of links that fall within each category. So now I have a nice sense of how many of those links fell within those 3 categories. But one thing that is kind of tricky about this line is that because you're nesting these functions, it's kind of hard to read what's going on. So a more recent update to R is this movement to try and make data more easy, or make the code more easily readable. And one of the ways you can do that is by using what's called a pipe operator. So this essentially, these 4 lines are doing the same work as these 2 lines, but it's a little bit easier to see what's happening. And I'll walk you through it so you can, to explain what the differences are. So first I still have this object that I want to create, and this time I'm going to call it action count 2. And I'm assigning all of this to it. And then what I want to use, again, that links data frame to begin. But what this pipe does is it takes the information that's in that links data frame and it pipes it into this first function, which is the filter function that we used earlier. And so it takes it and it says, okay, this is, up here you saw we had the links as one of the arguments. Instead of having to use it as an argument, we can just tell it what to filter on, because because this links is being piped into the function, is feeding into it. And then we can say, okay, now take the result of this filtering and pipe it into this next function, which is the count function, and use that column action, count using action as the main variable. And the nice thing about this, it's longer, so it's more lines of code, but it's easier to kind of follow what's happening here, and it's also easier to write, because it's kind of easier to think about, okay, well, I'm starting with this data frame, I want it to do this function, and then I want to take the result of this function and put it in this next function, and have that kind of flow from, beginning to end. So more and more people are using this pipe operator as a way to just make their code more readable and be able to think through their analyses and document them a little bit easier than using this nested function syntax. And then let's say we just wanted to learn a little bit more about the count function. Again, you can use that $count, and then it will tell you, oh, there's the topic count comes up in a couple of different areas. So then we have to choose, well, we're using the package dplyr, so we want to know about the count function in that particular package. Because since packages are written by multiple groups or individuals, you can't have the same function names used between multiple packages. So it's good to know, it's good that the help gives you the option of picking which package. So that way you can make sure, oh, I want this function to learn about this function in the dplyr package, as opposed to another package that you may not be using. So that's a helpful piece of information. So we have that object that we've created that we want to use for our analysis. And it's helpful to have these numbers and this this data frame. But let's just say I want a visual, a really quick and easy visual of how those links were categorized. So I want to make a bar plot of it. And one of the really nice things about R is because it's set up for statistical and data analysis, there's been a lot of effort put into creating packages that allow you to really set a lot of the details of your graphical parameters that give you a lot of control over how things are visualized or displayed. And so I'll just show you a brief example with the bar plot. So first I'm going to create the labels I want to use, and that's basically just the categories that were part of the spreadsheet. So you can see it's created an object called category. I use the C function to concatenate these three. So this is basically a vector with 3 elements that are called discard, keep, and update. And then I want to make sure that's the count that it uses for the bar plot is a vector. So it uses that to create the height of the bar plot. And this is just particular to the function for bar plot. I have to, in order to have it use the height, to use the count as the height, I have to make sure that the action count object is a vector. So I can make it a vector by using this function, and then using the object action count with the column n as the argument. So I'm basically telling it, make this this column, a vector. And now you can see down here, it's created this vector that has the 3 elements that are in the action count object. So the 27, 22, and 40. And those will serve as the heights for the bar plot. So then this is an example of the function that you can use to create the bar plot. And it gives you, you can use a lot of different arguments to set your parameters. So this is basically the name of the function. And then you want it to use the action count object with the column n as your input. Then you can set a title. So this is the main title equals recommended actions for content pages. You can then set the limits of your axes. So this is the limits of the y-axis. And then you can give it a title for your x-axis. Tell it how large to make the print or the font. Give a title for your y-axis. Set the color of your bar graph. And then give it the names that you want it to use. So in this case, it's that category label that I created earlier. So obviously a lot of control over the various aspects of the plot. And now you can see that when I run that line, the plot comes up in that lower right-hand corner, and all of the things I've set, the details that I've set in my bar plot function are here. So the plots or the bars themselves are green. I have my labels that are discard, keep, and update. I have my x-axis labeled, my y-axis labeled, and I can set the parameters for the size. So for instance, if I change this to 1 and ran it again, you can see it gets bigger. I could also change the limit of my y-axis if I wanted to. So now you see it becomes 100. So it's just really, and this is a nice, easy visualization of, oh, update, you know, most of the links fall into that update category, which is nice. So it's a nice way to visualize that data, make it easier to process, but also R gives you a lot of control over how you want to visualize that information, which is great. So that's just a basic introduction to R scripting and using RStudio and various functions and packages and how you can create plots. So now I'll go back to my PowerPoint and talk a little bit about resources that can help you get started in R and the R community. One of the really nice things that as I mentioned before about R is that there are a lot of free resources out there that aim to help people learn the language. One really easy, nice step-by-step one is the Beginner's Guide to R. Let's see if it'll actually, nope, well, it's not going to go, but this is a 3 or 4 step tutorial that shows you a lot of examples of what I just went through in more depth, but it's completely free and available online. In terms of syntax, this is a really helpful resource. It's the R Style Guide that shows you how to make your code really easily readable. So that helps when you're trying to come back, either when you're trying to come back and read it to do analyses or when you're sharing code with others. Following a consistent style can really help make it more readable and easily translatable for other people. There are a lot of books and courses out there for those who want to learn R. Coursera does an introduction to R, so does edX, so does DataCamp. All of them are free, or at least they were the last time I checked, and they provide a nice environment for both learning and applying what you're learning. One of the keys that I really found to learning a language is that you need to practice it on a pretty frequent basis. I'm always surprised because sometimes we do our analysis at only certain times of the year. So for example, for conference papers or for publications, and then we'll have a project that intervenes for a couple months, and then I'll have to come back to my R script. And it definitely still takes me some time to get reoriented when I'm out of practice. So it really does help to be able to put what you're learning into practice on a pretty frequent basis. And the nice thing about these courses is that they give you structure to do that by giving you not only guidance, but also data sets to work with so that you can learn R even if you have different data, even if it's different data from that you want to work with. And these 2 books are for data science. Is also, you can buy it, but it's also freely available on the web. And learning R is a good resource to start as well. So there are a fair number of good resources out there that are freely available if you want to learn. And in terms of the R community, there are a lot of different communities that are associated within that larger R community. So you have R bloggers, which is basically a blog where individuals provide examples of analyses that they've run and talk about packages that they've used. So they provide a lot of examples of different kinds of data analysis that can be really helpful. There are lots of meetups that are R focused, and those tend to be in-person meetups rather than, so that obviously Coursera and edX are those large scale MOOC platforms. So a lot of the interaction you're doing is virtual, which can still be really important and helpful, but it's also really nice to be able to work with a group in person. So there are a lot of meetup communities that focus on learning R programming. Our Reddit is just a handy community for looking up, asking questions, and getting feedback. Stack Overflow is another community where you can ask specific questions about R, and people will provide input or insight if they've run similar analyses. The R Consortium is a group of individuals who are associated with the development of R, and they also support a lot of these other communities in terms of helping build user groups to help others learn R. And then finally, R Ladies is probably one of the more recent ones that's been created, and it really is focused on helping women get involved in programming, specifically with R. We have an R Ladies, they have chapters all over the United States. We have one here in Charlottesville, and it's been really great because it's created a community of individuals, and we have a meetup group where we get together on a semi-weekly basis, and we're actually right now going through the R for Data Science book chapter by chapter and working through the exercises together and kind of talking through what questions we have about syntax or about how some of the packages work and the functions work, which has been a really great way for me to revisit and learn some aspects of R that I didn't learn on the job. So I would definitely recommend looking up through meetup.com and R Ladies, which are R Ladies meetups are also, at least in Charlottesville and I think elsewhere, are open to men and women. So it's not solely geared towards females, but it is a way of trying to get women involved in development and using R programming. So that's my very basic, quick intro to R. Angie will kind of drop or join us now because I asked her to talk a little bit about some of her experience with using R in museums, because I tend to use it more specifically for research purposes, but I also wanted to talk a little bit about some other examples.
Cool. I know we've only got a couple of minutes left, Beth. We do have a question that's come in from Kyle Lamont at the Glenbow Museum. He asks, is it possible to connect a report server so that you can present your data analysis in real time? Or are you using all offline data?
No, you can. So I don't know specifically about a report server, but I do know, for instance, that we have a Postgres SQL server that we use for our database, and there's a package called Postgres R where we can download that data live from the database and get any updates that we have in real time. So I know at least you can connect to various databases. I'm not as sure about servers, other types of servers,
Yeah,
but I would think you could.
Kyle, one of the ways that you can use R is not just in the IDE, but also in sort of another environment. So if that environment is connected up to a pipeline, then you're good to go as well. So we use a number of different interpreters in Data Lab and then connect that back to a pipeline. That would be one of the ways you could do that. Cool. Thank you so much for that, Beth. That was such a great run through. I'll just check with the group. If you have any other questions, please feel welcome to put them in that chat facility. So out of interest, Beth, how do you share that output side of your projects with your users? What sort of, do you sort of cut and paste into a PowerPoint presentation? Do you knit the file and then share it? What's your preferred method?
So we often, we're trying to develop different ways of doing this. Right now, our outputs, especially our graphical outputs, are available on our website. For our code, we don't have it up on GitHub yet. We're hoping to soon, but right now, frankly, we're mostly emailing things back and forth, which we're looking to try and change to make it a little bit more open and transparent. But we are also hoping to knit and do more tutorials in R, because that's one of the nice parts about the IDE that I didn't even get into is helping with presenting that code in a more readable way. So not just the script, but also creating HTML pages that you can use to create tutorials. We haven't done that yet, but we're hoping to in the next year or so.
Yeah, that's kind of how we use our internally, is that when we think about sort of research and development, we probably use it more on the research side of things, where we're more inclined to use something like Python on the development side, because we need, to run performant models at extreme scale in terms of data and number of venues that they're running for and the load that we're putting on them. So we sort of see Python as a good match for that, but R, like you say, is so easy to learn. It's loved by many. So it's a lot easier for the research side of things. So we'll do our initial analysis and initial model development and then beta testing right up until the point where we're absolutely sure we've got a productizable model, and at that point translate it over into Python. And doing things like whether they're quite analytical or insights-based projects right through to forecasting projects. Those are the kind of use cases that we've used. So whether that's forecasting visitation or revenue or behavior. And I've seen some other museums using it for things like analyzing TripAdvisor reviews. A lot on collections management analysis. I think the British Museum, their data science group a few years ago was doing a lot in that space.
That's great. I know that using it to analyze Google Analytics data too can be really helpful.
Yeah, to really extend the power that you're getting out of the data that they collect, because their initial analysis sort of only gives you so much. Is there any other questions that the group wanted to ask? I know we're sort of quite firm on 4 o'clock, 1 minute to spare. Anything else to add, Beth?
Nope, I'm
great.
good.
Well, thank you so much for such a wonderful introduction. I hope everybody is jazzed up to go and try out R themselves. In the chat facility, we've posted a few of those links that Beth pointed to on where you can download the IDE and some resources, some of the books that are available. So go forth and conquer, and looking forward to hearing back everybody's reports on how you've been getting on. Yeah. Thanks very much, Beth.
Thank you.